Hi everyone, welcome to Orgo Essentials, not your basic organic chemistry tutorial, episode 10. In this episode, we'll learn the steps to name an organic compound and practice these steps with a variety of molecules. Let's get started. Organic nomenclature may seem like a complicated mess of prefixes and suffixes, impossible to comprehend and even more impossible to replicate. Nomenclature is one of the most important topics of the foundations of organic chemistry. Without a solid understanding, it's hard to fully master any additional concepts. Unfortunately, it's also a topic that many classes rush through. I hope this video makes up for that. While it's true that there are a lot of things to remember about organic nomenclature, and that there are a lot of prefixes and suffixes, the whole process is actually very systematic. This is all thanks to IUPAC, the International Union of Pure and Applied Chemistry. Before them, there were just a whole lot of common names floating around. Names that describe a compound's uses or odor, not its physical structure. Now, every organic molecule has a name that specifically describes how many carbons it has, where any substituents are located, the shape of the molecule, and so on. Not only can organic chemists draw a molecule from just its name, but they can also name a molecule based on its structure, and every other organic chemist will be able to replicate it. There are just a few simple steps to learn, and then you'll be able to do this too. Step 1. Find the longest carbon chain and assign the molecule a corresponding root name. Go through the molecule and trace along the longest chain of carbon atoms that you can find. Make sure to take your time with this step. There can sometimes be a lot of side chains, and the longest carbon chain isn't always the most obvious. Go back and double check if you're not sure that you found the longest chain. Once you're confident, you can assign the molecule its root name, based on the number of carbons in the chain you found. If there is just one carbon, then the root name will be meth. 2 carbons means eth, 3 means prop, and 4 means bute. These first 4 root names may seem kind of random, but fortunately, there's a helpful mnemonic that is personally my favorite part about organic chemistry. Monkeys eat purple bananas, with each beginning letter correlating to a root name. Luckily, the root names after 4 carbon atoms just match the number: pent, hex, hept, oct, non, and dec. You shouldn't need to memorize much more than these. Though they go as far up as numbers do, additional root names can all be found in reference books or online. Here's a chart with the first 10 root names. Step 2. Figure out the type of molecule and give it its corresponding suffix. The suffix of an organic molecule depends on its functional groups, which we learned about in the last video. If there's no functional group, no multiple bonds or atoms other than hydrogen and carbon, then the molecule is an alkane and receives the suffix -ane. This, attached to the root name from before, will be the final name of the molecule. Easy, right? Luckily for us, not every organic molecule is this easy to name. Most have functional groups, with their own suffix to remember. We covered these in the last video, but here's a chart to remind you. Alcohols get the suffix -ol, amines get amine, ketones get -one, aldehydes get either al or aldehyde, and carboxylic acids get oic acid. The other functional groups we covered in the last video, esters, amides, and ethers, are a bit more complicated, so we'll look at them a little later. If there are multiple functional groups in a molecule, don't panic. All you have to do is add the suffix of the highest priority functional group. How do you figure this out? Consult a reference book or online resources. The priorities of functional groups isn't really based on something very tangible. IUPAC established this list. So you either have to memorize them or look them up. Remember that double and triple bonds can also count as functional groups. Before you attach the suffix for a double or triple bond, make sure that the longest carbon chain includes it. Then, add -ene for a double bond and -ine for a triple bond. Halogen atoms can also be functional groups. Don't worry, we'll look at some of these types of molecules later. Step 3. Add the corresponding prefixes for any substituents. writing the number of the carbon it's attached to, then a hyphen, then the prefix, then the rest of the molecule's name. If there are any substituents, meaning parts of the molecule that branch off the main carbon chain, then you're not done yet. First, you have to number all the carbons in that main chain. Write the numbering in whichever direction results in the lowest number being next to the substituent. If one direction means that the substituent branches off the second carbon, and the other means it branches off the fourth, then choose that first way. Now, simply figure out the prefix for the substituent and write that after the number carbon and a hyphen. If there are more than one substituents, write them in alphabetical order. Finally, something you don't have to look up. If there are more than one of the same substituent, you have to include how many there are. We do this by adding the prefixes di, tri, and so on. This goes right before the substituent's prefix. We'll see an example of this later in the video. This was a lot of information, and it may seem overwhelming. Let's do some practice, and hopefully all of these steps get to be second nature for you. Today, we're only going to look at basic alkanes, alkenes, and alkynes, with no other functional groups. For practice with more complicated molecules, look at later videos. Number 1. The molecular formula of this molecule is C3H8. Let's see if we can figure out the name. The first step, remember, is to count the number of carbons in the longest chain. In this case, it's easy. 1, 2, 3. Now, we have to remember the base name for a molecule with 3 carbons. Remember that monkeys eat purple bananas, so 3 means P, so prop. Now, the second step is to figure out the type of molecule. We don't see any functional groups or multiple bonds, just hydrogen and carbon in single bonds. So this molecule is an alkane, with the suffix ane. Let's combine those two parts that we figured out, prop and ane. Propane. Number 2. Next is a molecule with the formula C6H14. If you're noticing a pattern with molecular formulas, it's because there is one. Alkanes, with nothing but single hydrogen-carbon bonds, generally take on the molecular formula CnH2n plus 2. Let's see if we can name this alkane. First, we have to count the number of carbons in the longest carbon chain. Be careful with this one. It might seem like simply going across the bottom is the longest chain, but when we include the top 2 carbons, we see that the longest chain actually contains 5 carbons. This means that the root name will be pent. Let's mark off those carbons, just so we know we've accounted for them. Next, we account for the type of molecule. We already know that this one is an alkane, so the suffix will be ane. When we combine the two parts we have, pent and ane, we get pentane. Now, step 3. We can see that there's still a carbon left, on the far right. This carbon and its hydrogen friends will be our molecule substituent. As you may know, a CH3 group is called a methyl group. If you didn't know this, you can always refer back to the prefix chart from step 1. A substituent of just 2 carbons and hydrogens is called an ethyl group. One of 3 carbons and its hydrogens is a propyl group, and then a butyl group, and so on. Remember that these groups only contain carbon, hydrogen, and single bonds. Anything else, and they receive a different name. Anyway, now we know that the last carbon is classified as a methyl group, but we have to be clear about its location, too. We have to number the carbons in the carbon chain. Let's try both directions, and see which way results in the lowest number where the methyl group branches off. If we start on the left and go like this, then that carbon gets a 3. The other way, and it gets a 3 as well. So, in this case, the numbering doesn't matter. That methyl group is at the 3rd carbon, no matter what. Let's put it all together. Pentane, from before. The methyl, remember that the number goes first, then a hyphen, then the rest of the name. Combined, we get 3-methylpentane. Not bad. 3. Finally, we have this molecule, with the molecular formula C12H35. It looks complicated, but let's see if we can get a systematic name for it. First, we have to go through and find the longest carbon chain. Note that there are a couple of correct ways to count this chain, shown here, but they all result in a chain of 7 carbons. This correlates to a root name of hept. Next, we have to figure out the type of molecule. Though the molecular formula doesn't follow the pattern CnH2n plus 2, we can still tell this is an alkane, because it's a hydrocarbon with nothing but single bonds. So we can add the suffix -ane. Finally, we have to add all the substituents. Like with before, let's mark off the atoms we've already accounted for, all of those carbons in the chain and their hydrogens. We're left with a methyl group here. Remember that methyl means CH3. An ethyl group here. Similarly, ethyl means CH2CH3. And 2 more methyl groups here and here. Let's try out the different numbering directions. If we start at the top, we get the first substituent, methyl, on the 3rd carbon. If we try the other way, starting on numbering at the bottom, like this, then the first substituent is a methyl on the 2nd carbon. This second way results in a smaller number on the first substituent, so we'll use that way. When we look at the positions of all the substituents with this carbon numbering system, we get a methyl on the 2nd, 4th, and 5th carbon, and an ethyl on the 3rd. Let's go ahead and write those. 2, 4, 5 methyl, and 3 ethyl. Remember that, when there are more than one of the same substituent, we add in prefixes to indicate so. In this case, that means that the methyl section will turn into 2,4,5 trimethyl. Finally, we just have to remember that the ethyl section will go first, since substituents are listed in alphabetical order. Let's put it all together. 3-ethyl 2,4,5 trimethyl heptane. Not the prettiest word to say, but we did it. That's it for this video. As usual, I've included a document with some basic nomenclature practice problems. Remember, practice makes better. If you have any questions so far, feel free to email me or comment down below. The next video will be about more advanced concepts in nomenclature. I'll see you then.